Very good afternoon to all of you. And after hearing to Dr. Abhijit Singh, I don't know how much I can speak more. But what I'd like to do today is I'll briefly kind of highlights the type of work that we are doing at IIT Kharagpur in our group and our allied groups. So I'll be talking about the application of data analysis and assimilation in delineating groundwater scenarios in India. And I am at the Department of Geology and Geophysics with joint in charge in the School of Environmental Science and Engineering here at IIT Kharagpur. But before I go for the presentation, I'd like to highlight my students. I have plenty of master students, but I'm here have the PhD students. I have quite a few actually. So this includes a list of some of my former PhD students and my present PhD students, without whom I could not have done any of the work. And they work in different domains, including looking at the very basic science, the physics and the chemistry of water and groundwater, as well as looking at policy advisory to hydrogeosciences. So framing policies and advising policies that possibly can be of any benefit to building our nation. And also, like, I do collaborate quite a bit in across the world, and here is a list of some of my present collaborators. So I would like to acknowledge them before I go in. So groundwater, the concept of groundwater in making of India is not new. Okay, in present times, possibly we have used it only in the last 50 years or something, but like, the concept of groundwater was there. And there is this depiction of Arjuna piercing the ground to feed Vishwa with water, was actually groundwater. Like, you can see the fountain of groundwater coming out from the ground, and this is almost like 1000 BCE, so at least 3000 years from the stories of Mahabharata. And even if you look at the pages of history, okay, this might be mythology, might be legend, but if you even look at the pages of history, Mohenjo-daro, which is one of the most ancient civilization in this planet, do have hundreds of groundwater wells. Similar examples are also from Odisha, Delhi, Gujarat, and everywhere. So the concept of groundwater has been there, but possibly it was not in the extreme in which we are using it today. So modern India is thoroughly relied on groundwater for its sustenance, and all this needs data. Okay, so these people, like who are taking the bath or going for the agricultural practices, doing it through their profession, through their practices. But we as scientists, when you go to understand what the philosophy and what the practices are going on, we do need to understand the data that is generating. And when we talk about data, in present world, we're swamped with data. So we have to make the difference between good data and bad data, quality data, non-quality data, and so on, to generate the knowledge out of it. So data is something which you can possibly gather easily, but knowledge is something which is very privileged, and that's why we come. So at present, just like Dr. Singh said, almost 85% of the water of this country, mostly groundwater, would be used in irrigational purposes, and only about 15% goes for other sources, which is very skewed from the other developing countries. So if you look at the literature, literature in the sense of media sources and literature, in the last 15 years or so, the science media has been flooded by news that India is going through what they called groundwater drought. So it's one such country which is having the largest volume of groundwater withdrawal in the human history. Okay, it's in the history of human being in this planet, and India is one such country which is going through that, through that process and the crisis. So one of the questions that we are trying to address, in my group at IIT Kharagpur, is how much safe groundwater is available in the Indian subcontinent, and what is the future. So how we can understand the present scenario and possibly predict the future. Now the reason for all these uncertainties is that India has a very diverse geology vis-a-vis hydrogeologic setup, so the groundwater is not distributed uniformly throughout the country, and it is much more available in the northern parts of country than the southern parts. However, the northern part is also known to be highly geogenically polluted. So although if quantity is available in the northern parts of the country, the quality is not. So as such, the volume of water you eventually get for your sustenance, for your purposes, may not be as much as you can quantify. Now, of course, I can understand that you can strategize that water for different other purposes, non-human purposes, but that we have to do. We haven't done that yet. So what we are trying to do here, and again, I'm just going to provide you the snapshot, is to see like how groundwater usage might be impacting food security. This is a map of that was published by my friend Richard Taylor at Nature Climate Change a couple of years back, and you can see that these are all the areas where groundwater irrigation is going on across the world, and you can see one area within it where it's totally red, and that's northern India, right? So this is where what you called most of the food production of South Asia or maybe Asia is going on. So if this is the water-stressed crop yield areas in 2020, this is 2050 predicted, of course, and you can see like much of the world has turned brown and India has turned almost deep brown to gray, which means that India is one such country which will be totally underprivileged with availability of groundwater. So what we are trying to do is trying to understand the availability of groundwater in the what we call the Indus Ganga Brahmaputra basin, which is regarded as the breadbasket of South Asia. Most of the crop production of this subcontinent or maybe South Asia itself do take place in this area. So what we are trying to do using agglomeration of remotely sensed data, in situ data like field-based data, as well as numerical simulation, we are trying to figure out those differences and what can be the future scenarios. The other application that we are looking at is the sea level rise and the coastal vulnerability. Now, this figure doesn't come out that well, but you can see these lines here. These are the lines of tropical storms. And these lines actually indicate like where the tropical storms would hit in the South Asia context. And all of them kind of converge into the Bay of Bengal in the West Bengal, Bangladesh coastal belt. So when the storm comes in, so comes the seawater. And the groundwater which comes tries to drain out to the seawater has a constant dynamic interactions. And these would result to like a vulnerability for one of the best, sorry, this box kind of came down, it should be here, for the best bioreserve in this planet, that's the Sundarbans. And accordingly, the ecosystem of Sundarban is changing over the last 50 years or so. And you can see that the sea level is constantly rising, and there is loss of land, loss of resources, loss of economy, eventually destroying the whole coastal parts of eastern India. So what we are trying to do is using highly sensed data from those locations along with satellite based measurements to understand how much of coastal erosion and things like that are going on, and what is the impact of that to the groundwater scenario of eastern India. Now the Minister of Earth Science has really taken up a mission. They're going to start in April, where they are going to stretch this to the rest of the country and look at this coastal ecosystem and water interactions across the country. The other important thing, now this is not really groundwater but surface water, but surface water and groundwater are two sides of the same coin. We have a high resolution station at Varanasi. So this is one of the pilot sites that we are studying, and we have been, for the last 4 years, we have invested a lot of effort, both understanding the river Ganga as well as the groundwater in that area, plus the geology. And we have installed high level sensors across the city as well as in the river, and the sensors are providing like magnificent data. So this is the peak that we are getting from the 2016 flood, which is about 13.3 meters above, the regular water level. We have also installed, and that was, Dr. Singh was instrumental in that, in installation of real-time high-resolution water quality monitors. So like the Varanasi water is getting real-time monitored. Every 15 minutes we are recording the data, and it is getting swarmed back to our server on both the water level and the water quality. And this data is getting fed into our models. We are also using groundwater to understand the recharge. And I'm showing here the last 5 years, well, not last 5 years, but recent 5 years, and we kind of try to estimate how much groundwater recharge might have taken place across the country. Similarly, using another ensemble of satellite data as well as ground data, we also trying to estimate if vegetation index can be an indicator of groundwater storage. Because groundwater is something you don't see really. You can estimate, but you don't see. So if vegetation, which is a more visible thing, can be used to understand the change in storage. We are also working with some of my colleagues at NASA to understand or to generate real-time climatic and groundwater drought. So we are using an ensemble of models along with satellite data that are feeding, real-time feeding to the models, and we can kind of predict actually now the scenario of groundwater drought that might be coming in the next few months. And then, which is my real expertise through my student, we also have been doing in situ measurements of groundwater levels. Mostly when I didn't do it, this is mostly the Ministry of Water Resource data, Central Groundwater Board, and eventually we have calculated out the groundwater level changes across the last 20 years. And through that, we, as Dr. Singh said, we have been able to find out in places in Gujarat and Andhra Pradesh, there are places where the groundwater actually is coming up, which is in contrast to what you typically think about. So in addition to the ground-based data, we used this GRACE satellite data, and we work very closely with NASA, and they are swamping their data to our databases. We are taking those data to feed into our models, and eventually developing the groundwater storage change on a monthly scale across the country for the last 20 years, 15 years. And this satellite and model based output has been found to be in reasonably good correlation with the ground based data that the ministry has been generating. So we are very pleased with the output that we have gotten so far. And as Dr. Singh mentioned, that these data essentially, if processed properly, can generate knowledge that might be in the benefit, of framing policies and management strategies for future times. So this is, a snapshot diagram of the groundwater storage change from 2003 to 2014, and what you can possibly notice that in 2003, the pink area, which is water excess, has now become water deficit. Whereas, the red area, which was water deficit, because of policy changes, has now turned pink, water excess. And last but not the least, so this is, what's happening now. But, with collaboration with the Computer Science Department in the Institute, specifically Professor Sudeshna Sarkar and her team, and Professor Pavitra Mitra, we are generating this artificial intelligence based model to predict the future groundwater resource of this country. So, the future, is the sky is the limit. And, with proper human resource, proper data resource, and proper, of course, truthfulness of working for science, I think we can do miracle even in India. Thank you so much.
How do you measure the level of groundwater? I mean, if I want to measure the level of groundwater of my local area, how can I do it?
Okay, so the groundwater level that I showed at least, those were measured by the ministry. I didn't do it. So Dr. Singh, Dr. Shaha's team did it. However, what you can do is you can go to an open well, and knowing that it is tapping what you call the superficial aquifer, unconfined aquifer, you can use a tape or like a electronic tape or just even like a rope with some kind of weight. Take the depth, knowing the elevation, you can measure out the water level of that area.
In respect of West Bengal, what is your prediction after 10 years?
Okay, all right. So prediction is West Bengal. Yeah, we still have water excess, but it's declining fast. So assuming like there is a status quo of how things are happening now, we if you just go out through the train and you will see like during the crop irrigation time, all the fields are flood irrigated, right? There is almost the whole scenario looks like flood, but actually those are groundwater that has been taken out from the subsurface. Now one of my friend in biotechnology, again this is just hearsay, told me that rice doesn't need that water. So that water that stands there actually is not required by the rice. It's actually a symbiotic bacteria or a microbe that stays. I don't understand the bacteria and virus, can make the difference. So there is a symbiotic microbe that grows in those roots of the rice, which needs anoxia or reductive situation or chemical systems. That stagnant water actually creates a redox disequilibrium, and it's only because of that bacteria to stay alive, which is a catalyst to the growth of the rice. So if you can somehow genetically manage that, possibly you don't need that water. So it's basically a waste. Yeah, please.
The bigger issue in Bengal is all the 12 districts which border Bangladesh. They have a severe arsenic contamination. That's a much bigger issue in Bengal at the moment.
Yeah.
Which we need to address.
All right, is it time? Thank you very much.
Thank you so much.